In this video, we are continuing our midterm review by doing some definition of the derivative practice problems. So the first example that I want us to try is from the midterm review, question 5, part C. So we have this function t of x, 1 over x minus 7, and we want to find t prime of x using the limit definition of the derivative. So pause the video, this time for 4 minutes to try this question. So 4, 3, 2, 1, pause the video. Pause the video for 4 minutes to try this problem using the limit definition of the derivative. Alright, so hopefully you've done that. Hopefully you've paused the video to try this for 4 minutes. So there are two forms for the limit definition of the derivative. So let's just review those two forms. So the first form is, we could take the limit as h approaches 0 of, and typically I'd write something like f of x plus h and minus f of x over h. But in this case, my function is called t, so let's just write t instead of f. So my function is called t, so let's just keep it t. And this is t prime of x. That limit represents the derivative of t at x. But we have one other form for the definition of the derivative. And in that other form, we have a limit as x approaches a. And normally I would write f of x minus f of a over x minus a. Except our function is not f, it's t, so let's just change the f's to t's. So this is a t, oh no, looks more like a plus sign. So t of a, and this first thing is t of x. Okay, so we have these two forms for the limit definition of the derivative. Either will work. So either will work. So let's just pick one of them and do it with that form. So, but let's do form 2. So both of them will work just fine. But let's do form 2 to practice form 2 a little bit more. All right, so form 2 says, I forgot to write something, which is this form 2 is the derivative of t, but evaluated at a, t prime of a. So if we do form 2, we get t prime of a equals the limit as x approaches a of, so first I have to write t of x, but t of x was given to us. That was 1 over x minus 7. Okay, so t of x is this 1 over x minus 7. Then I have to do minus what t of a is. So t of a, with t of a, I have a in the parentheses, which means we have to plug a into our function where the variable is, where the x is. And doing that, we get 1 over a minus 7. So 1 over a minus 7, that is t of a. So that whole thing is divided by x minus a. Okay, so that is the setup right there. We've set this thing up, now we need to simplify. So we have this limit as x approaches a, and in the numerator, I am subtracting two fractions. And we do that by getting a common denominator. So we have 1 over x minus 7 minus 1 over a minus 7. I'm leaving myself a bunch of extra space so I can get this common denominator. So for this first fraction, I would multiply the top and the bottom by a minus 7 by the other denominator. There's nothing smaller I can do because there's no common factors here. And then for the second fraction, I would multiply by x minus 7 over x minus 7. So the first denominator. All right, so we have this all over x minus a. So we have the limit as x approaches a, and multiplying this out, 1 times a minus 7 is a minus 7, and then we have this minus sign, and after the minus sign, we're going to have 1 times x minus 7. So when I have this minus sign, it means it's got to be minus everything that comes after it. So let's not forget that I need a parentheses around that. Okay, so 1 times x minus 7 is x minus 7. And then I have x minus 7 times a minus 7 in the denominator. Okay, I'm going to give myself a little bit of extra room here. So let's let's scooch this down. And then for this x minus a that's on the denominator, let's write that as being over 1. And when we divide by a fraction, that's the same thing as multiplying by the reciprocal, 1 over x minus a. All right, so we have this limit as x approaches a. And in the numerator, after we distribute the negative, we will end up with just a minus x, because the 7's cancel. So in the denominator, we have this x minus 7. We have this a minus 7. And then times 1 over. I notice that with x minus a, it is super close to the a minus x in the numerator. It would be exactly like it if I factored out a negative. If we factored out a negative, we'd be left with a minus x in the parentheses. Okay, and that's nice for us, because now the a minus x cancels. And that's usually the step where we know, oh, this is going to work. Our definition of the derivative is going to work, because something on the top and the bottom canceled. So we have the limit as x approaches a. On the top, we have 1. On the bottom, we'll have the negative sign. Let's just move the negative to the front. And then x minus 7 times a minus 7. And now let's plug in. So if I plug in the a for the x, we'd get negative 1 over a minus 7, because you're plugging in the a for the x, and then a minus 7, which is negative 1 over a minus 7 squared. Okay, so that's our derivative, negative 1 over a minus 7 squared. But let's just remember what our original variable was in our function. Like, was it a? So no, our original variable was x. So anytime you do this second form for the definition of the derivative, it'll give you the answer in terms of a, whatever, so the variable a. So if I need to switch back to the original variable, I do that as my last step. Okay, so let's switch back to the original variable. So let's switch it back to the original variable. And if we do that, we get t prime of x instead of t prime of a is negative 1 over x minus 7 squared. So that's our derivative. Okay, so with these definition of the derivative problems, it's important that we're doing it actually using this limit definition and not using shortcuts that we will learn about later. So we'll learn about a couple of shortcuts for doing this type of derivative using something called the quotient rule. So don't worry about that because we don't know it yet. And something called the chain rule. It's also possible to do this using something called the chain rule. So if you've seen those before, for a problem like this, we can't use them because it asks us to just do this using the limit definition. So we have to do it using one of these two forms. All right, so let's do another example, but a more conceptual one. All right, so this is problem 15a from, whoops, I should just say midterm review. Okay, so we have this limit as h approaches 0 of 2 plus h cubed minus 8. And this limit represents f prime of a. And that means this is actually the derivative of a certain function evaluated at a certain point, a certain x value, which I'm calling a. And the goal is to find f of x and to find a. So, in other words, basically someone started the limit definition and has plugged in stuff for part of it, and it wants us to work backwards and figure out, well, what's f of x and what's a? What are those pieces? So pause the video this time for 2 minutes to try this question. 4, 3, 2, 1, pause the video. Pause the video for 2 minutes to try this one. Okay, so hopefully you've done that. Hopefully you've paused the video for about 2 minutes. So there's a question that I want to ask, which is, this is supposed to represent a derivative, so it looks like a limit definition of the derivative, but which form? Which form does it look like? Does it look like the limit as h approaches 0 of f of x plus h minus f of x all over h? and that one is equal to f prime of x. So does it look like that form, or does it look like the one where you take the limit as x approaches a of f of x minus f of a all over x minus a? And that limit definition, this one equals f prime of a. So which one does it look like? If you weren't totally sure on how to start, pause the video, this time for just 30 seconds, and answer this. Which one is it more like? 4, 3, 2, 1, pause the video. Pause it for 30 seconds and see if you can identify which form is a closer match with. All right, so let's start to talk about it. So it's a closer match to the first form, because both of these, the first form, and what I have in my problem, has a limit as h approaches 0. So that's a strong indicator. It's the first form. And then there are other indicators, like there's an h in the bottom instead of like x minus a or x minus a number or something like that. Okay, so what we need to do to figure out f of x and a now is to sort of match parts of our problem to parts of this general limit definition. So in particular, it looks like what matches up with the f of x plus h. So what matches up with this part right here is the first part of this numerator, the 2 plus h cubed. It looks like f of x plus h is 2 plus h cubed. And if we think about this being x plus h, that's what's sort of being plugged into our function, which we don't know what it is yet. Well, on the other side, it looks like 2 plus h is being plugged into something. It's being plugged into like a cube, a third power. So based off of that, it seems like the 2 plus h is matching up well with the x plus h. So it seems like our x value is 2 in this problem. Okay, and what's f of x? What's the overarching function? Well, the 2 plus h is getting plugged into a cube. So our function is x cubed. Just as a check now, if I were to write out the whole thing, it should give me my problem. So if I were to write out the limit as h approaches 0 of f of x plus h minus f of x all over h, using this function, I should get our original problem. If I zoom it out a little bit so I can still see it, we get the limit as h approaches 0. So if f of x plus h is f of 2 plus h, f of x is f of 2, because we're saying our x value is 2, all over h. So we have the limit as h approaches 0. And now for f of 2 plus h, if I take 2 plus h and I plug that into our function, so if I plug 2 plus h in for the x, so whatever's in the parentheses, I got to plug that in for my variable, we'll get 2 plus h being cubed. And then f of 2 is 2 being cubed, so, and there's minus sign in between, and then h. And if I look at that, that's our original problem. So that's good. That means we have identified what the correct f of x is and what the correct point is. So let's just write it out. F of x is x cubed, and we were calling our point a instead of x. So the a value is 2. And that is our answer right there. So in terms of our goals for this video, for the section, we have talked about how to do some definition of the derivative problems. We've looked at a more algebraic question, actually doing the definition of the derivative, and a more conceptual problem, looking at a limit and working backwards to recognize what the function it's the derivative of and at what point. So as you continue to prep for the midterm, I'd encourage you to do as many of the midterm review problems as you can. In particular, prioritize doing the high priority. That's a little bit redundant when I say it. Do the high priority questions first. So those are the ones with a star and the ones marked with a plus sign.